So we're having another lesson today on tree diagrams. You'll have had one yesterday that's kind of introduced the concept of trees and what trees are good for. Trees are really, really good for sorting things out when we're doing something more than once, when we've got two events happening. We have sets of branches for each event, and they kind of fan out and show us all the different outcomes. So in this case, the two events are flipping a coin and rolling a die. So you organize your tree by having the outcomes from the first event happening. So there's only two outcomes from flipping a coin, head or tail, it branches off. And then we have the second event kind of branch out from each outcome of the first event. So if we get a head on the coin, then we can go 1, 2, 3, 4, 5, 6, and that gives us our first 6 outcomes. Or if we get a tail from the first event, then we can get 1, 2, 3, 4, 5, 6 as well, right? That kind of shows us how many things can happen, right? From doing a coin and then a die, right? It's two lots of 6. That means when we're doing probability questions, we can start by making all of our fractions, out of 12, because we can see what the 12 things are, right? So trees are really good at that. And a tree like this is really good when all of your events have the same chance of happening, right? Head and tail, same chance. 1, 2, 3, 4, 5, 6, they all have the same chance as each other. It gets a bit trickier today because we're going to be dealing with events that don't have the same chance of happening, and those chances can change as you move through your tree. So here's an example. We've got a member of a Year 9 class. Was just working with my Year 9 class for this example. We'll call them 9B. I don't know which one's A, which one's B. Member of my Year 9 class is being abducted by aliens. Then the aliens decide one person isn't enough. They abduct another person. And then we're going to calculate the probability of getting a person who is away, using the term loosely, on leadership camp at the moment, or not. So if we were doing it like yesterday's class, every member of my class would need their own branch, and you wouldn't know it to look at what's going on in Google Classroom, but there are 17 students in my class, so if we're figuring out who they're going to abduct the first time, we need to have 17 different branches, right? I started with a few initials, I got bored, I don't want to have 17 different branches, and then like 17 more branches coming off it. That means there's hundreds of branches in my tree. So we need a more efficient way of figuring out which type of person gets abducted, because we're looking for people on camp. So we're not going to give each individual student their own branch. It would be too hard. So what we're going to do is make groups. This will make life much easier. We have a group of students who are on camp and a group of students who are not on camp. They get one branch each. Now, the thing to think about with a situation like this is these two events do not have the same chance of happening, because out of my 17 students, only 3 of them are away on camp. So the difference today is when you draw your tree, you need to put a probability on each of the branches. So there are 3 out of 17 who are on camp, and there are 4 out of 17 who are not. All right, if I don't put weights on it, then that implies that they have the same chance of happening, right? We didn't have to put a fraction on this first one because heads and tails is the same. I mean, you could say that heads is half, you could say that tails is half, but it's a waste of energy. We know there are 2 branches, we know they're the same chance of happening, so we don't worry about it. We have to do it in this case because this is a much less chance of happening than this, right? This should be 14, sorry. So 3 out of 17 on camp, 14 out of 17 not on camp. Look, it adds up to 17. Okay, so we've done our first event, right? We're a 3 out of 17 chance to get a camper, a 14 out of 17 chance to not get a camper. So where these questions get really spicy, the problem we have is they're abducting 2 people, not just one, right? If it was just one person, we'd be happy to leave it, right, with a 3 out of 17 chance for camp and a 14 out of 17 chance not for camp. But the problem is they're abducting people and they're not giving them back. All right, so we have to change the probabilities of our second event, right? So this is basically our first event, and you should do that first, right? We've got 2 choices, camp or not. And then once we've figured out the chances of those happening, we can then go down those paths and figure out the chance of the second person being a camper or not. But it's going to change because you have to imagine that someone's gone now from our group, right? So our chances aren't out of 17 anymore. They're going to be out of 16, right? That's the new probability. That's the new number on the bottom because one of these 17 people is gone. There are 16 left. Now in this particular pathway here, right, we're going down this branch first. This is the branch where someone who was on camp got abducted. So there's not 3 of them left anymore. There's not 3 people in that group. There's only 2. And that means that everyone else who wasn't on camp has to still be here, right? These 2 numbers have to still add up to 16, right? So 2 people here, that means the other 14 are in this group. Now it's different going down this path because in this first situation, the person abducted wasn't away on camp, all right? So the probabilities are again out of 16 because 1 person got taken. It's just that this time, they're from this group. So that means I started with 14 people who didn't go on camp. 1 of them got abducted by aliens. I'm down to 13. And then to make sure these numbers add up to 16, I put my 3 campers here. Okay, so my probabilities are all labeled. Okay, what we need now though is the overall chances of these things happening. And we have learnt previously that when you want 2 things to happen, right? So as we're moving through our trees, when you want 2 things to happen, you just have to times their probabilities together. Okay, so we need the actual probability of going through these 2 branches, or this one and this one, or these ones, or the bottom 2. So first of all, our first outcome could be that we get a camp person and another camp person. All right, so you have to go through this branch and that branch. It means you have to times 3/17 by 2/16. Okay, that means times top by top, bottom by bottom. Use your calculator. So we're not going to simplify these down at the moment, though your calculator would do that for you. It's basically 6 out of 272. That's the chance of that happening. Okay, very, very small because this is a very, very small group, right? 6 out of 272 isn't a very high probability. The chance of getting a camper and then someone who isn't, again, you have to go down this path and that path, and now you're timesing this one by that one, 3/17 and 14/16. So unsimplified, you would get, 42 out of 272. Okay, we've got our first 2. We're moving on to the bottom half of the tree diagram, so we're getting a not camp person, then a camp person in that order. But again, timesing these 2 together, I should get the same answer. That is also a 42 out of 272 chance. Then we move on to the most likely outcome, which is to get someone who doesn't go to camp and someone else who doesn't, because that is almost everyone. So to go not and then not again, it's out of 272. And 14 times 13 is 182. And we now have our 4 outcomes with their probabilities all lined up. So this is all the hard work done now. We put all this effort into making a tree, putting weights on all the branches, and then multiplying through the tree to get individual probabilities. So when it's time to actually find a probability, all the information is right there in front of us. So once you've filled out your tree, get asked simple questions like, what is the chance of getting 2 people who went to camp? And you can just quite clearly look at the section where you've got 2 campers, right? That's just this one up here. Right, this is the only event where I've got 2 C's. So it's 6 out of 272, and then you can let your calculator simplify that down. The chance of getting no campers, right, that's just down here, right, N and then N, right, there are no C's in this, so that's 182 out of 272 before you let your calculator simplify it. Then the chance of getting exactly 1 camper, right, that means 1 who did and 1 who didn't, that's this one, and it's that one. So all you have to do if there's more than one thing that's a winner for you is just add them up. Right, we multiplied to get through the tree to get our answers, but now that 2 of these are good, we just add them up. Right, so it's 42 out of 272 plus the other 42 out of 272, and then unsimplified, that means we've got an 84 out of 272 overall chance of getting exactly 1 camper. Right, doesn't matter whether they were the first one or the second one. Both of these outcomes are good, so we add them up. All right, so the challenge today really is to draw nice tree diagrams, to label them with their probabilities, and then to get through your branches and find the individual chances of each set of branches, of each group. That'll take a bit of effort. We're not setting a lot of questions today because we know that making trees that look like this, that have enough detail, that's going to take a lot of time and effort. Okay, so if you can draw nice trees, the questions will basically answer themselves. So good luck.